Assalamualaikum. Today, our group will present about power transfer and friction wear on bicycle gym.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ifan Zakri. I want to start our presentation about introduction. Mechanic of machine is a branch of engineering that deals with the study of machine and their mechanics. It involves the analysis of problems related to the hoist, friction, simple harmonic motion, velocity and acceleration diagram, friction and belt drive. Friction is an important concept in mechanics of machine. It is force that oppose motion between two surfaces that are in contact with each other. Power transmission can be achieved through various mechanics such as belt, chain, gear, and shaft. Belt drive are one of the most common mechanics used for power transmission. They are used to transmit power between two shafts that are not in the line with each other. Welcome to our Mechanic of Machine project. Our team consists of 5 members who are passionate about understanding the mechanic of machine. In the project, we will explore the fundamental principle of mechanic and their application in stationary bicycle.
Right now, I will present about background of case study in this presentation. Firstly, this bike has a weight of 68 kg and the dimension it has 1 to 1 cm for the length, 59 cm for the width and 132 for the height. This bike is manufactured by ABS Plastic and the components found in this bike are the saddle, seat post, seat slider, stabilizer bar, flywheel and belt drive. For the belt, it can be divided to several parts, which is polyval belt. It's made by polyurethane and it's where resistance, height, tensile and flexibility. Next is tooth synchronous rubber belt and it's made by Neurofin. It can improve the shear of material state. Plus, this bike has a mechanism that applies resistance to the pedals. To calculate the frictions and wear in this bike, there are some formula that we will be used. Firstly, the angle of contact, which is alpha equal to R1 minus R2 per S. Secondly, torsion, the formula is T1 plus T2 multiplied with R. And last but not least, maneuver force F1 minus F2 equal to R1 plus R2. That's all.
Literature review. A stationary bicycle is a piece of equipment used for indoor cycling activity. It is also known as exercise bike, spinning bike, spin bike or cycle. Similar to a stationary bicycle, it has handle, pedal and some form of handlebar. The majority of the time, stationary bicycles are found in gym, but some people also purchase them and ride them at home. The two topics we will discuss is friction. The resistance to relative motion between two bodies of contact is known as friction. The force of friction is exactly proportional to the applied load. It is independent of the area of the surface in contact. The electromagnetic interaction between the charged particle on the two surfaces of contact is thought to be the cause of friction. Second, the power transmission. A mechanical power transmission system uses simple machine, link and other mechanical power transmission component to move energy from its source to the point where it will be put to use for work. Almost all machines receive a power and motion from an input source in some way. Typically, an internal combustion engine or an electric motor use an input shaft and connection to provide rotary driving torque.
Assalamualaikum. My name is Aslan Husna and I will explain about the calculation of power transfer. For the calculation of the power transfer, we use an open belt drive. First of all, we have to find the length of the belt, which is 343.6217 centimeter. Next, we have to find the angle of contact. From that, we can get the theta value. In this experiment, we use 2 revolutions, which is 1500 and 3000 RPM. All the data that we get from the calculation have been shown, which is the velocity, value T1 minus T2, and also the torque.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Aimiti Muhammad Jumain and I will discuss the friction and wear calculation we use for this project. This experiment is to analyzing the friction and wear on the foot pedals of the indoor riding cycle will reveal how much power is required for a person to maintain their foot on the cycling pedal. When riding a bicycle, the bike pedal often holds the rider's foot at angle. By utilizing the formula F1 minus F2 equal coefficient R2 plus R1, the force may be calculated by solving the x-axis and y-axis components of the inclined plane. In order to prevent slipping, the user of an indoor cycling bike usually use an angle of 25 degree to 35 degree in relation to the pedal. The force exerted by the user's feet on the pedal is assumed to be 150 Newton, and the coefficient of the friction between the pedal and the user's shoes is assumed to be 1.2. Therefore, the first step is to determine how much effort is required for a human to maintain pedal equation at 35 and 35 degrees. So, R1 is F sin 35, R2 is 150 cos 35, F1 is F cos 35, and F2 is 150 sin 35. After we convert the data into the formula given, hence the minimum force needed by the person to stay at the pedals on the plane at 35 degree is 157.007 Newton. Therefore, the minimum force required by the individuals to maintain pedal equation on a plane at 25 degrees is 110.278 Newton. This prevents the person's feet to slip from the pedal. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Hazi. The transmission system of a spinning bike is used to transfer the power from the pedals to the flywheel. So, let me explain about the system is working. The flywheel is connected to the pedals through a chain or belt drive system. So, the chain or belt drive system is connected to the flywheel through a set of gears that allow the users to adjust the resistance of the bike. So, what is the chain of drive system? A chain drive system is a type of drive system that is used in spinning bike. So, the chain is attached to the pedals and then connected to the flywheel. So, for the pedal, the motion is transferred through the chain to the flywheel, and which is to create the spin. So, next, the belt drive system. The belt drive system is similar with the chain system, which is another type of drive system that used in spinning bikes. So the belt is also attached to the pedals and then connected to the flywheel, and the motion transfer through the belt and flywheel and then creates the spin. So when the topic of power transfer related to the spinning bike, it is mean the transfer of energy from the rider to the flywheel and brake pads. So, before calculate the angle of contact, we need to use this equation for calculating the belt friction, which is, firstly, we need to calculate the angle of the contact by using the formula sin alpha is equal to radius 1 minus radius 2 divided by x, and get the answer. For this calculation, we get 8.63 degree. Then we need to convert the answer to the radian and then calculate the two of the RPM states in the calculation. So we identify the volume, tension, and also the torque. For the topic 2, we are discussing about the friction and wear of a spinning bike. So the friction is the force that opposes motion between two surfaces that are in contact. So in the case of a spinning bike, friction is created between the flywheel and the brake pad to create resistance. So, where is the gradual loss of material from a surface due to the friction or the other mechanical action? So, in this case of a spinning bike, wear can develop on the brake pad or the chain or belt. So, in addition, increasing friction between two surfaces can also be useful to prevent slipping. So, for example, the treads on a tire increase friction between the tire and the road to prevent slipping. For the case of a spinning bike, increasing friction between the flywheel and the brake pad can also help to prevent slipping and provide a safer workout experience. So for the study case 2, we are discussing about the force components of the inclined plane. So we are using these two formula to calculate the force perpendicular to the pedal and the force parallel. So we detect that the F1 is the force perpendicular and the F2 is the parallel to the pedal. Then The R1 is the x-axis component of the inclined plane and the R2 is the y-axis component. So we have identified the minimum force required to maintain the pedal on a plane at 35 degrees based on the calculation. And then we also determining the bare minimum force. So that's all from me. Thank you.
In conclusion, indoor cycling bike is the example of how friction force and a bed system can be used. The single layer rubber material has a low coefficient of friction, so the open bed drive on the indoor cycling bike requires less lubrication. Other than that, friction serves to stop motion when two distinct surfaces come into contact, and friction resistance occurs when the pads apply pressure to the spinning bike. Frictional force must be overcome with some energy, which lowers the efficiency of power transfer or the output to input ratio. But there is risk for equipment wear and tear, which the indoor cycling bike needs to be serviced by changing the new belt when the belt is worn out. So that's all from me. Thank you.
I think that's all from us. Thank you.